Hello everyone. Can you guys see me and hear me? So everything that can go wrong is going wrong. My camera didn't connect, so I'm using my Mac camera, which is causing some issues. So little better, but yeah, so it's causing some issues. And hopefully I'm audible. And my whole setup where I was going to show you some restarting the bench won't help because we are not going to use the bench today. But the setup I had for SQL Essentials isn't working now. So there is some issue. So maybe restarting Visual Studio Code might help, but let's see. So I've been doing like a lot of setup here. Let me just VS Code, come on. Quit. Okay. Probably many left. That's why. I don't know. It's like 13 minutes late already. Hi, Hari Vignesh. How are you? So yeah, this is this episode. I don't know why website isn't updated automatically, but yeah, this is the episode we are on. By the way, 50th episode of Build with Hussain. Okay, they changed it a bit to throw Christmas stuff, but yeah, thanks everyone for supporting, for liking the series so much that we did like in 7 months we did 50 episodes, and that is something substantial, I guess, hours and hours of content, and hopefully it helped you improve a bit on some topics, or you found it cool, entertaining, whatever works for you. But yeah, glad I was able to do this and start from zero basically this year. But yeah, I'm proud of what we have achieved together. Yeah, enough of philosophy. Hi Neeraj, how are you? So yeah, so let's get back to this VS Code again. Hopefully this works this time. Come on, man. Nope, isn't working. So probably MySQL uninstall, install, please work. So it isn't working. So add connection command node will caused by the extension that contributes this. Okay. So let's try this. MySQL add connection doesn't work. What do I do now? So one more thing we can try, VS Code insiders. Yeah, if you notice I changed the wallpaper. But yeah, kind of cool. So let's see, we go into this. Okay, we already have MySQL here. Let's try. Okay, it isn't working. That's an issue. I want it working to be able to do this as I planned. Reload required. Okay, fine, reload. So this is a cool VS Code extension. Oh, it works. Localhost root. So this will basically connect to my local MariaDB, right? Which I've installed. So now it shows me all the database are inside them, inside this DB server. And a lot of this random are like one per site that I have on my local. Plus this bank is the one we are going to work on today. So if you see closely in this, I will explain what it is. We'll start from the very scratch. Hi Patrick, how are you? Hi Tanishk. Okay, so this is the bank database that I have created, and you can get it too. Just check the description. There's the first link. I have a GitHub gist. which contains SQL commands. So just copy and paste on a new database in your whatever MySQL or MariaDB, and you should also have the same database and data that I have here. So just, yeah, this one. Yeah, this one I have shared it in the chat, so the link is there. So this will basically create 3 tables: bank account, customer, and branch, and also some sample data for the 3 of this. Cool. So if you want to follow along, just go and grab this and run it, and you will have the same exact database state that I have. And it will be fun. So we are not going to stop at exactly 2 hours today. We will complete whatever I have in my mind, whether it takes 3 hours, but we will do it. Cool. Who is ready for it? Just put emojis. Let me just grab a bottle of water as well. Cool. Let's do it. So hopefully you learn something new and have fun too. Let's get back to here. So let me just go to my whiteboard that we built together, if you recall. So I will add a new page here. SQL rect. Okay, let's start. Okay. So what is SQL? Let's start from there, right? And some say SQL, some say SQL. So let's demystify that first. So, okay, horrible handwriting as of now, but this is SQL and this is SQL, right? Let's go S, normal pen size. Okay, this is better. Cool. So sometimes I will say SQL, SQL, both are fine, but there is a small history behind it. So the first version of this language, what was actually SQL, right? SEQUEL, simple English query language, right? It was done by Oracle. So they built a database, Oracle or IBM, I don't recall exactly, but one of them developed this language to talk to database systems. And they named it simple English query language because it resembles English language in so many ways, as we'll see. But later it was standardized, so other database systems could use it, and like you just have to learn one language to talk to many relational database. I'm coming to that, just wait for a bit. So then it became SQL, the standard, simple query, not simple, structured query language. Even I am like structured query language. Okay, not simple, structured. Earlier it was simple English query language. So if we search for SQL, SQL full form, let's search structured English query language. Okay, I'm confused here, but let's be clear so we learn the right thing. So structured English query language, and then it became SQL, which is structured query language. So English was dropped. So now it is just SQL. But yeah, that is the history. Doesn't matter much. Pronounce it however you want, but we are going to learn SQL. So structured query language. Come on, Hussain. Come to your good state of mind. Important topic. Okay, so structured query language. So this is a language in which we query stuff, right, through a database system, and especially relational databases system. Okay, so let's go down, exit pen mode. Okay, so relational databases, right? So basically the core entity that relational databases have is called a table. So they store data in tables, right? What do tables means? So tables have rows and columns. Okay, so there are columns. So for example, if you have a student table, right? Horrible handwriting again. So columns will be first name, last name, date of birth, and the actual data will be the rows, right? So John Doe and his date of birth, Jenny Doe. So this will be the actual data. So this columns are also called attributes in official terms, right? And rows are called tuples or records or just rows, right? Tuples, records, rows. So this is the actual data. And why relational? Because then you can have many of these tables in a single database, right? You can have n number of tables. So for example, one more table, right? Fee or fee record or whatever you want to call, and all have the same column row structure. So maybe fee has which student, right? For this fee was collected. Fee collection, let's call it fee collection. And what was the amount of fees paid and what was the date on which the fees were paid, right? So student can be again, so this student can have an admission number, say 1, and then this refers to that. And somehow will learn more about this relationship between the tables, but somehow we can refer this table in another table, so forming a relationship between them, right? So that is why it is called relational database. So tables have relations between them. That as simple as that. Let's not complicate it even further, right? So that is how it happens. Rows, columns, tables, and many n number of tables. So if you are coming from Frappe or you want to learn about Frappe, basically when you create a doc type, a normal doc type, Frappe will create a database table for you in behind the scenes, as we will see at a later point in this series after we have covered some basics. Cool. So where do we start? Okay, this was it. I am not going too much over theory. What we do at Build with Hussain is directly jump into stuff. So here I am. So what I will do is, you can actually install either MariaDB or MySQL. So if you have already a Frappe instance running, you will already have your MariaDB. So if you just do MySQL and your root password and this, it will take you to MariaDB console, and you can also execute your stuff here. So show databases, right? So you can see, so one database server has many databases. So this can be like one database, this is another. So I have a school database. So let's check that. So use school, right? I want to use this database. And now let's see show, let me just zoom in, show tables. Right? So it just has one table called employee, right? So show tables is a special command. Again, depends on the database you are using. For MySQL and MariaDB, it is show tables. Cool. So what else? So it's not clearing. So let's do command Control L. That doesn't work. I'm using a new terminal, by the way. Just trying it out. But yeah, it's fine. So as you can see, there is just one table, and you can run those commands that I have given to you in a new database. So you can create a new database called, let's see, where is it running? Come on. Okay, let me just go to settings, appearance, pin to bottom, much better. Now we can run command here. Okay. Okay. Using a new terminal is like this. Ha! Let me go from here. Okay. Wrong time to experiment with stuff. Classic mode. What is that? Oh, it collapses it. Okay. I'm still learning, so that is fine. So what were we doing? Yeah, create database bank. Just create a new database and paste in the queries I have given you in the, what do you say, gist, GitHub gist. Cool. So I'm just not going to interact through console. I'm just going to use a VS Code extension that will give me just a nice UI when I execute queries. That's the only reason. So I will just do new query, and whatever I type here, right? So show tables, zoom in, I can just, okay, let's save, not save it, it's fine. And I can do run query, right? This comes with the extension, and this will show me a nice output that we can better visualize, right? So this shows me that I have 3 tables: bank account, branch, and customer. Cool. So this is an hypothetical bank system that I have modeled just for this training. So bank account, branch, and customer. So customer can be anyone. So let's, so you can see what a customer looks like by running DESC customer, right? Run query, and it will show you what all columns it has, right? We saw it in the browser that there is a table called customer, right? And it has this many columns. It has an ID, first name, last name, PAN, and date of birth, right? And each column has a type, right? So it is this ID is an integer column. First name is a varchar, basically string, if you are familiar with Python or any other normal programming language, of at max 50 characters. Last name is also a string of at max 50 characters. There is a PAN number. So this is in India in personal account, primary account number or something. Let's see what PAN is. So it's like a social security number in the United States. And then there is date of birth, which is the date column, right? And yeah. So we can use the create table command to create new tables. But yeah, the primary thing today we are going to do is to learn to query stuff, to get data in the form we want, right? And the data we want. So here we have 3 tables. So one is customer, branch, and bank account. So let's start with customer. So here I have some questions prepared that we have to answer through writing SQL here. So we'll write SQL here, and we want to get the results that we want, right? So let's minimize this even further. Cool. So let's disable Copilot so it doesn't complete our SQL queries. So the simplest of tasks that we have, the first question, is basically show all the data that is inside this customer table, right? So let's write. So you want to do select, right? Star, I will explain what I'm doing, from customer, semicolon. So I want to select, star means everything, every column, right? I want all the columns from customer. This is the table name. Let's run it. And if you see, it shows me, let me just zoom out a bit. It shows me the ID, first name, last name, PAN, DOB of all the customers. So here we have 15 customers, right? And it also prettifies the date. So this is by extension, not by SQL itself. And there are PAN numbers here, random PAN numbers. But yeah, this is the simplest of SQL query, right? So select everything. But what if we only want the first name and last name, right? So now instead of star, you can do first name, comma, last name, the column names. And again, hit run. And as you can see, now we only have first name and last name, right? So very, very simple language, right? Structured query language, structured English query language, anything you want to call, but resembles English, right? You are just saying go SQL, just select the first name and last name columns from this customer table, right? Similarly, if you want to view all the columns from a bank account, select star. So you can write it in multiple rows, multiple lines, or in a single line as well. So SQL doesn't care. Select star from bank account. So you need to know the name of the table. Let's run the query. And as you can see, now we have bank accounts. And by the way, side note, SQL is a case insensitive language in contrast to languages like Python, which are case sensitive. So capital FOR is different than small FOR. But here, small select or select with a capital T doesn't matter, works the same. Cool. So select, I like it this way, because it's more standard, and write the capital. This means reserved keywords or keywords that belong to SQL, and these are our cool. So again, we can run it. And if you just want balance, what do you do now? I just want to view the balance column. Go ahead, write it first. So just a small change. Instead of getting all the columns, I will do get balance, and I will run this query. Right now we have the balance column. Cool. This was the first question, right? That is fine. Get all the columns, get 2 columns. Now what do we want? We want to see, so this is the next question, the customers whose name starts with A. What is it? Select star from customer. This will give us all the rows, right? This will give us all the rows, as we already saw. So if you run this will give us all the rows. But I just want the rows. So I'm kind of filtering, right? I'm filtering the rows. So this gives all the rows, but I want to filter. I want only those. So let's start with, that starts with capital A, right? So I should get Ananya, Amit, Aishwarya, and Aditi, 4 records. So now here is where the where clause comes in. So these are called select clause, from clause, and this order matters, by the way. So this can't be this. So you have to first write select, then from. So you'll find a lot of resources online on the order of how to write this and how it is actually executed, which is like more advanced use case. Select star from customer, where now we want to filter, where first name like, so this is an operator, A, this means starts with A. So A and then whatever it may be, I don't care, right? So let's run this query and I'll explain again. So now we got Ananya, Amit, Arjun, Aishwarya, and Aditi, which is exactly what we wanted. If we wanted B, then let's do B. No data, it means nobody, we don't have anybody whose name starts with B. So let's try C. Again, no data. Let's do R. We have Rahul, Rajesh, and Rohan, right? Let's answer one more question. So we want, so let me just grab my notebook which has the questions. Okay, I'm back. So I wrote the question somewhere. Okay. So we want to list all the customers born after 1st of January 2000, right? So where date of birth is after 1st of January. So let's write that. So we want date of birth, which is DOB, after, which means greater than 01/01/2000. Let's run this query and you can see we did something wrong or what. This is not formatting it correctly. Okay, something is wrong. This should have, let's run this in directly in MySQL console. Use bank. Okay, let's see what I'm missing here. Okay, now this is an important thing. The format should be correct, right? So databases like won't guess that, okay, whatever format maybe you gave it like this, right? what will it do with this, right? So the date format which you have to provide should be like proper standard. So one of the standard format is this YYYY MMDD. Cool. So let's run, and now this should be correct. And which is correct, of course? 2002, 2001, 2005, 2003, and June 2000, right? So we made a mistake, but it was for the learning that the date should be in proper format, otherwise it will give you some hallucinations. And as far as I know, this should also work, right? This also works. So either you do dash dash or slash slash, but it should be YYYYY MMDD. Cool. And you can use greater than, less than. So if you want to check who were born before or on, right, you can use this operator. And now you can see 1990, 1985, and you just want their last name maybe. So let's just get last name. Cool. So now we have the last name. So selecting last name, which is the column name, from customer, which is the table name, where date of birth is before 1st of Jan, on or before. So this is less than equal to this. Cool. So by the way, if you have any questions, do ask in the chat. Cool. So where were we? So let's do something more interesting. So the next question is, list all customers born in the month of March. So this is a little bit advanced. So how do you do it, right? We know how to select all the columns from customer. But now the actual question here is that were born in March, right? From customer, where? So now what filter do I apply for March? I can't do greater than, less than, because I don't know the year. If I had knew the year, then it would be easy. But I want March. Year doesn't matter. Anybody, any idea? There are a few ways to do it. Anyone? No one? So repeat please. I meant that I want the customers who were, right? Customers, run SQL query, who are born in the month of March, right? So I want Ananya, Priya, and Neha, and Meera. So Salim says MM equal to March. What is MM? So we don't have any column named MM, right? We just have ID, first name, last name, PAN, and date of birth. And obviously, date of birth is the column that contains the date of birth. Yeah, how do I extract the month part from this? So let's try one thing. So we know that the date format is in something like this, right? 2000, 03, and something like 18 March, my birthday, right? So how do we extract this? When extract this from, so Yogesh is suggesting a syntax that probably works in PostgreSQL. But yeah, so let's try one thing simple. So I want a date string, right, that looks like this. Let's try this. I don't know if it will work or not, but let's try this. So we want something, a date that looks like this, right? Exactly, March, whoever is born in March will have a date of birth that looks like this. Let's try it out. Where date of birth like this. Let's run it. And what do we have here? Exactly what we wanted, right? So this was one way to do it. Simple, right? We just want a date of birth that looks like this. So this is the like operator. This is very useful. So I can tell you about like operator. So what it does is you can give it a pattern and it will match your string. So this only works with varchar, date and the like. So it won't work with numbers or anything, integers, etc. It won't work. But since they are this is represented as a string, and when we filtered even we used the string, right? So this has two characters. One is this and one is the underscore character, right? So this means the modulo operator, if you will. This is not a modulo operator here. This is percentage symbol. It represents any number of characters, any number of any character, right? This means any one character, right? Let's learn. These are very useful. So percentage means any number of any character, so even 0 works. So this will match. So let's take examples. So my first example is, right? We are coming to that, Lewis. Functions. We wanted to do it without functions. So let's keep it simple at first, and then we'll gradually take more complex stuff. But yeah, what are the examples of this? So the one we took, right, starts with A, and I don't care what comes after this and how many characters are there, right? So this will match A, B, XYZ, whatever. It just means that it should start with A, and whatever comes after, whatever, even if there is no character after, then also works, right? So 0 or more characters of any character. This doesn't care what character, okay? So let's take a more complex example. So can you tell me what this will match? A percent A. Anyone? What this will do? Try to think what kind of strings this will match. A, then any wildcard character, then a small a. What this will do? Everything between A and A. No. ID 4. Yeah, this is one of the matches of this. Very correct. So what we are saying to SQL is, the like operator is, that anything that starts with A, whatever comes in between, I don't care, but it should end with a small a. So if we run this query, right, where first name like capital A modulo small a, run query, and we get Ananya and Aishwarya because start with capital A, ends with A, capital A, small a. Awesome. Cool. Let's keep going. So I figured out a new way. So when you do this in what do you say, YouTube, right, it somehow shows a animation. I don't know. Now it is not showing, but it does sometimes. Cool. So this will match Nanya AA, right? So SQL is case insensitive. So you can make it case sensitive, by the way, but by default it is case insensitive. Got it? Cool. So you can search for Google on how to make this search case sensitive. Let's do it. Case sensitive like in SQL. So this is what we are figuring out, right? We can't cover everything in 3 hours, but you should be able to figure out a lot of stuff. So too much complex stuff. Case sensitive. Complex stuff, but yeah, it is possible. Cool. And it varies from database to database, by the way. Cool. So now let's take an example of this thing, right? A pattern that contains this. So these are called patterns, and this is a wildcard operator as in like character. Okay, so now just guess what this will do. A dash dash, so there is a dash, 2 dashes are separate, right? I'm putting just a space to, so you can see that these are separate. D. So now what will happen? So as I said, any one character, right? So this will exactly match A, B, C, D, A, M, G, D, but won't match ABD. Why? Because we need 2 characters here, right? Exactly 1 character per underscore. And here we just have 1. So A matched, then B matched, but this character didn't match, and then there is a D. So didn't match, so it is a false. Make sense? So these are just the 2 characters that are special for creating patterns like this. Cool. So this was the like operator. So the last question we did was DOB like. So you can either do like small or capital, and then we did this, which gave us those who were born in March. But there is a better way to do this. So there are functions in SQL, just like functions in Python, that you can call. So select. Now I'm just going to execute this. Don't ask why, just wait a bit. And what this gives you is the current date and time. So Saturday 30 December 6:51 Indian Standard Time, right? So I just selected now. I didn't say what table, what not. So this kind of stuff also you can do. So you can also run this. Select 2 plus 2. I'll run this and you get 4. So use SQL as a calculator now. Go ahead. So you can do that. So there are many variety of functions. So now is very useful. So it will give you the current date and time. We also have cur date, which will give you just the date. We also have cur time, which will just give you the current time. So HHMMSS. So just search for single row functions, MySQL or MariaDB, and you will get a list of all the functions that are available. But yeah, pretty useful. So the question we had before was that we wanted every customer who was born in March. So what do? So we have a function that can help us extract a month from a date string. 2003-11. We'll execute this. So this gives you the month part. So we could have replaced select star from customer where what? DOB, not DOB, month of DOB. So I want to check whether the month of DOB is equal to 3. Now this is much more readable and efficient than the like operator checking, right? So very useful. So you run the same, you will get the same results. So if we run this, you will get Ananya, Priya, Neha and Meera. All of those are born in March, but this is cooler, right? Nice. So these are called single row functions because they apply on every row. So it checks every row. We are going to learn the next thing is aggregate functions, which will come to. But yeah, cool. Let me show you a few more of this. So useful ones at least. So similar to month, we have year, which will give you the year part of this date string. We have day name, I guess, day name, which will give you the day name basically. So today is Saturday. Cool. Useful, right? So sometimes you might need this. Okay, you want to show this in your, so this can be shown in this as well. So if I just uncomment this. So this functions work anywhere. So even when I'm doing this, I can add a column here. So we want to check which day they were born. So I can say this. So Ananya was born on a Saturday. So it took the date of birth and extracted the day name. Priya was born on a Tuesday, Neha was born on Tuesday, and Meera was born on a Thursday. Pretty cool, right? So very useful. So you can use either here or where, doesn't matter. But yeah, functions quite useful. Some more functions. So these were date functions. Month, day. If you just do day, right, it will give you 11 because 11 is the day part. Cool. So now you can combine. You can say, okay, where day name of DOB is Saturday. So whoever was born in, what is the day today? Saturday, right? So we want to check whoever was born on a Saturday. Maybe we should celebrate again. So Ananya was born on Saturday and Rajesh was born on a Saturday. Awesome. All sorts of cool stuff. I really like SQL. So simple. You don't have to care what is happening behind the scene. You don't have to do any conversions, kind of treats data as strings. But yeah, cool. That is that. But yeah, let's proceed and let me show you some string functions. Select. Let's do one thing. Let's bring back the SQL query, and instead of doing day name, I will keep it at this, and we'll select the first name, comma, last name, right? And now I want the first name all capital. So there is a function for that. UCase. Let's run it. And now we have uppercase of first name, Rahul, Sneha, Vikram. Similarly, there is L case. L case. Let's run it. And you get Rahul Kumar. So now this is all lowercase. Cool. Lot of functions. Uppercase, lowercase. There is also, I think, trimming functions like ltrim, rtrim, right, which will trim basically if your string has some spaces in between and later. So let's say Zan, and you can do select trim. So it will trim the leading and trailing spaces. So this is similar to, right, it trimmed the spaces from before and after. Cool. Lot of them. Just search for it and you will get a list, or let me know, I will share a list later. But yeah, cool. So this was very useful. Now you can play around. So why are you wearing a jacket inside? It's very cold here, man. I don't know. It's like, I feel cold. But yeah, it's not an air conditioned room. So the window is open. So the temperature outside is the temperature inside. Kind of what we learned in physics, but yeah, probably. So Yogesh says, can we use select star from customer where day name? Yeah. So if you don't want to hard code, right? So he says select day name from now. So this will give us Saturday, and then you can use this in your where clause. That's fine too. So combine functions. So you can say, okay, L case. So Saturday comes in lowercase. Combine functions, play around. The best way to learn is play around. You won't learn by just watching me do this, but grab the database, play around. I'll give you some questions, practice questions if you want, but yeah, play around, get some queries, and you should be good to go. Cool. So let's learn some more stuff. So the next question is, get the list of customers, first name, last name, and ID in order of last name. So SQL, so when you do this, right, select star from customer. So it doesn't keep an internal order as such. So you can't expect it to be sorted by first name or last name or anything. It probably looks like it was sorted in the order which they were inserted, right? But the internal structure is random. You can't depend on it. That is why we have another clause, right? Order by, right? What do you want to sort the result by? So probably if you want it to be sorted by first name, now you can see it was sorted by first name in alphabetical order. So Aditi comes first, Aishwarya, Amit, Ananya. If you, doesn't matter, as you can see, it is sorted. And if you want to sort by last name, C for Chatterjee comes first, D for Desai, G for Gupta, Iyer, Rao, Reddy, Sharma, and Singh. Cool. So this is order by, pretty cool. And if you want descending, right? So suppose you want descending. So A will come last, Z will come first. So let's do last name, first name. By default, it will do ascending, but we can say DESC, and it will then do descending. So Vikram first, Varun, and A should be last. Make sense? You can do multiple. You can do a comma and say then sort by last name. Right. But yeah, this is what it is. Cool. Order by. If you don't do, you will get some order, not your preference, but you can then just apply order by. And order by should always come. So you can't do this. Order by first name where, right? First name where last name like K. So if you see here, it says error in your SQL syntax, right? Use the right syntax. There is an error at this place because where can't come after order by. So this order is important in a SQL. So select come first, then from, then where, then order by, right? So we can remove this. And now we have two results. So we said where last name is like this, so starts with a K, right? Yeah, so Yogesh says, can you show how we can count the customer whose DOB is for a particular day? Awesome, we will do that. Good question, we'll do that. Yeah, we'll do that, don't worry. So a nice question to do. First we have to learn aggregate functions, but yeah, we'll learn that. So what did we do? We wanted all the columns from customer where last name is like this. Like this means starts with a K. I don't care what comes after. And then after you have found this, just order them by their first name. So Neha comes first, Rahul comes second, right? And if you do DSC, then Rahul will come first, Neha will come second. Awesome. Cool. So this was order by. And you can do equality as well. So I want where ID is equal to 3. So this will give me the customer row, like all the columns, where ID is 3, right? Vikram's record. So I just want to get the first name and PAN of this guy. Now you get first name and PAN. Cool. Easy peasy. Okay, build with Hussain. Probably Frappe cloud is down. Fine. Cool. So this was this. Any doubts till now? Any doubts till now? Before we proceed to more interesting stuff, of course. Parapa, parapa. So the question now is, right? Question is all the number of customers. So you want to write a SQL query to get the number of customers right? Total number of customers, right? So what are the total number of customers, right? So if you see, we can do this. So we can go and count. There are 15 customers, but what if there are thousands of customers and we want to get the exact count? We can't just do select star, go and count it, right? So there are some things called aggregate functions, right? So let's go exit pen mode, go here, and now what we are learning about are called aggregate functions. What are they called? Aggregate functions. Like I says, the beard looks cool. So I'm not maintaining it. I don't know. So I'm very lazy in terms of maintaining my hair and beard. But yeah, probably I need to get a cut. Like I'm not going to trim my beard, but some maintenance is required. Cool. Yeah, we are digressing here, but yeah, thanks. Come on, yeah. So we were learning about exit pen mode, aggregate functions. Let's increase the size and come on. Yeah, pen. Cool. So what are we doing here? So the normal functions we looked at, right? What did they do? So suppose we had a month column, or let's say we have first name column, right? First name, Rakesh, Rajesh, Ronnie. And we said we want to select, right? Lowercase. So we applied the lowercase function on the first name column. First name, it's too thin. Let me do this. Yeah, it will be better with mouse, I guess. Yeah. Right? So this should give me Rajesh in all capitals. Rajesh. Right? Then it will give me Rakesh, whatever, like not in capital but lowercase. So I want capital, then I can do U, so that will be uppercase, right? So these are single row functions because lowercase went and it got applied to Rakesh, Rajesh and every single row, right? So then we got Rajesh, Rakesh capital. But aggregate functions, Joshi Mamani, how do I pronounce your name? Is J, what do you say? Silent? Ose or Jose Mamani. Sorry, but I'm trying to learn the pronunciation of your name. Cool. So where were we? We were learning about aggregate functions. So in contrast to the functions we learned, which are called single row functions, month, day, now, right? What we are learning now applies to a group of rows altogether, right? So there are like 5 very important ones. So note them down if you want to, but probably you will know. There is count, C-O-U-N-T, count. We'll learn step by step. We can duplicate this. Next we have sum. Let's duplicate. Command D should work, but it isn't working. Sum, min, max, and average. So these are aggregate functions that will let you apply, like this get applied to multiple rows, right? So suppose I have a column, pen, okay. Say total, this is 2000, this is 4000, 5000, right? So I want to sum this column, right? So what should the answer I'm expecting is 5000 plus 4000 plus 2000. So that is 11,000 if I'm a bit correct at the math. 9,000 plus 2,000 is 11,000. That's fine. So how do I do that, right? Because this involves multiple rows. I can't just say sum of 2,000, right? I want to say that find the sum of this column. So then I can use the sum aggregate function, right? Sum of total. So what SQL will do is go ahead and sum this column, right? So let's try it out. So suppose I have this bank account table, which has this balance column, and I want to check what is the total balance in the bank, right? For any customer. So let's do this. We want to select sum of balance and run the query. So it is 1,49,800, right? So it went ahead and summed the balance column. So it went and did what? Summed all this. So what you will say now, if you understand one, you can understand like any. So if you want to find the minimum of that column, so in this case, what will be the minimum? 2,000, 4,000, 5,000. So the minimum is 2,000. So we're expecting that SQL will find the minimum and return to us. So let's come back, and instead of doing sum, we'll do what's the minimum balance that anybody has. So who is the poorest guy, right? 3,000. And similarly, we have max. Who is the richest guy, right? So 15,000, probably in dollars. But yeah, this is how it is. Probably in INR, not in dollars, because Indian bank. But yeah, 15,000 is the max, and min is, sorry, you are not applying minimum to a particular row, right? You are applying to a group of rows. So minimum this. So what does count do? So what was our original question? So it was total number of customers. So you can either do this. So I want to count how many ID are there. Count ID in customer. So 15. Yeah, 15 customers, which is the correct answer. So bear in mind, count, min, max, this don't count null. So null values are empty values. So if you don't provide a value for any particular row in a column, it is null. N-U-L-L. Means undefined or not present. Cool. So this doesn't count that. So if we just do this, right? Let's do select star from customer, and we enter a new row here that has say ID null, right? So it won't count it, right? Lucky says, I'm getting demotivated every day now. I think AI is already taken over. Most companies have almost stopped hiring, and all of the hard work that we're doing is going to get wasted. Okay. So I think AI will never be able to replace the creativity. Whatever, like hot take you want to oppose, like that's fine, but never. So ChatGPT can give you a resume, but that can't be any crafted and personalized that a human being would prepare. ChatGPT can give you images, generated images, mid journey or something, but can ever give you like a painting that you would like to hang in a museum that is worth millions. ChatGPT won't give you any emails that contain like the personality or empathy. I can judge right now if you send me the answers to the Frappe interview questions, writing ChatGPT, I can, that's easy how I can get it. And in terms of companies, right, they can get the software, they can get some amount of code written by AI, but I don't think humans are replaceable completely. It will facilitate. I use AI like ChatGPT. I use ChatGPT like whatever they call it, GitHub Copilot, right? That facilitates, that increases the productivity, but with mundane tasks, not with analytical thinking or anything like that. So don't be demotivated. Learn the skills, learn whatever your mind says that this is interesting, I should learn it. Don't care about whether AI can do it or not. That's the only thing. But yeah, let's focus on this now. So what you can do is, if you want to count the rows, right, not the ID or anything, you want to count what rows are there, doesn't matter null or anything like that, but this is how it is. So it will just count all the rows. So we should get the same answer, 15, but now it is much better. So this is kind of a trick to count the number of rows, not pertaining to any column. So battery is low, let's get it charging. Cool. As I said, I have full battery usually, but since today everything is going wrong, this also goes wrong. But yeah, we will be motivated, we'll continue to do work, and yeah, that is that. So select count star from customer. This will give you the number of total number of customers, right? If you want to count the total number of bank accounts, just do bank count 20 bank accounts, right? So that is that. Cool. So one more was left, average, right? So by the name it suggests AVG will give you the average of a particular column. So let's see what the average balance. So we can say AVG balance 7,490. This is the average balance. Cool. Nice. Any doubts till now? So we covered a lot of stuff, selecting columns, all columns, particular columns, and we saw where you can select, okay, you can say I just want the count of the customers, right, who were born in March. So month of DOB is 3. 4, right? So this all still remains the same. Even you can combine stuff. So this is like programming. You learn if else, you learn for loops, but if doesn't go away. You can mix and match. So yeah, that was that. And you can also find the whatever you want, sum average of whatever. Cool. So this was combining aggregate functions with where. So it will first go and find those rows where date of birth has the month as 3, which means they are born in March, and then it will apply this aggregate functions on those rows, right? So on those 4 rows it applied, and then find out it is 4. Cool. Yeah. Let's go one step further. Now the question is total, like number of branches, number of accounts in each branch. That's the next question. Number of accounts. And that is a tough one. Wait. Yeah, not a tough one. Accounts in each branch. Nothing is tough in SQL like that, as long as you're keeping it simple. Cool. Number of accounts in each branch. So we can get, let's see what branch, what bank account has. So branch code is there, right? So we can count all bank accounts just by doing this that we learned, right? So this will show you 20. But how do we get for each branch? So the output should look something like, is there a table? Okay, if not, let's draw a table. So what they want is, whoever wrote the questions, me, that this should be like this. So this should show the branch code, right? And this should show the how many accounts are there, right? So probably it will say 101 has 4 accounts, right? 102 has 5 accounts, right? So instead of showing the count of all the rows, we first want to group the rows based on branch code, right? So whatever rows belong to, let me show you visually. So we have the rows that belong to branch code 101, and then there will be rows that belong to 102, and then there will be rows belong to 103, and so on and so forth, right? So this will be a bucket of rows. So suppose there are 4 rows, so this will count and tell 4, right? Suppose there are 5 rows in this, like 5 records that belong to this branch, then it should show 5. Then suppose we have 3 rows here, so it will show 103 as 3, right? So what is happening here actually? So here basically we are, before applying the aggregate function, before counting, we are grouping them into separate buckets using a particular column. In this case it was branch code, right? So instead of applying to all rows, it will apply to each bucket and give a record for each of those. So very straightforward in SQL. We have a group by clause. Let's go back. And here, I'll just go here and say group by branch, right? So I will say run my SQL query. So now it went ahead and counted based on branch. So let's also select the branch. 101 has 2 accounts. 102 has 2 accounts, 103 has 1 account, 104 has 2 accounts, and so on and so forth, which is exactly what we wanted. Where did it go? Yeah. Right. So this looks ugly, right? The column title. So we can use aliasing. Aliasing will let us give a custom column name to this when showing the result. So you can say as how many. Now it just changed the column name to how many, and you can change branch to branch code as branch code, right? 101 has 2, 102 has 2. So just applying group by, it went ahead, grouped the rows in branches, and then applied the count star. Make sense? Is group by clear now? If you understand, it is pretty straightforward what it does. So before applying the aggregate function, it will group the rows it got. So you can even combine this with where. So where branch in. So let's take this opportunity to learn one more operator. 101, 102, 105. So I just want this to fetch the branches which have an ID, like this is the branch code 101, 102 and 105, and only for them group them, then apply the count star. So where still holds, right? Where is optional, but yeah, in operator will let you basically check whether this branch code is any one of this 101, 102 or 105. Cool. Is it clear? Awful silence after the Lucky's comment. Have fun, chill. Anyone? Or are you guys not with me? I was just checking a tweet. Until I get a reply from anyone. Yeah. Go ahead, Louis. Eat spaghetti or whatever you like. But yeah, see you. So where was I? Yeah, we answered that question. Total number of customers in each branch. So the next question is total balance of accounts by type. Okay, so let's delete this. Let's try to answer this question. So let's select star to check what this question means. So there is a type column, right? So this can be either savings or current, savings account or current account. So what do we want now? We want the balance, total balance by account. So that will look like something like this. So instead of this, this should be account type, total balance. So instead of doing total balance for all the stuff, we want to do this based on this. So savings has this much balance, savings type of accounts, and current has this much balance, right? So what do we actually want? We want SQL to first group by account type, 2 buckets, and then apply a total or sum, right? Easy. We learned that if you just do sum of balance, right, what it will do? It will give you the sum of all the rows, like all the balance in the balance column. But if we just go ahead and group by type, so this gives you 2, which means there are 2 types, but how do we know that? So I can just, so now it shows current account has sum of balance of this. Current has 90,500 and savings has 59,300. Make sense? So you can again use aliasing to say account type, better column names, nothing fancy. So account type, and sum of balance can be named something else. Sum of balance as total balance, right? Just to make this pretty, the output table. So account type is savings, the total balance is this. So it went, grouped the rows by account type. So for each different account, it created a bucket, and for the savings bucket, it totaled. For the current bucket, it totaled because we applied the sum. If you applied count star here, it will just ahead and count the number of accounts. Savings account are 11, current account are 9, right? If you don't group by, and we have to remove this as well because it won't know what account type is. Let's apply the semicolon, and as you can see, we have total 20 accounts. 11 were that, 9 was this. Matches up. Cool. Now aggregate functions plus group by is clear. So if you are not using any aggregate function, right? So suppose let's do type, then you apply a group by type. Useless, right? Like it's not you. It will give you unique types, but it's not that useful. Just applying group by. Cool. Clear to me? Awesome. Very useful. Group by plus aggregate functions. What's the next question on the list? There are no more questions here, so we will take from here to raw mode, whatever comes to mind. So there was one question. So Yogesh suggested that, can you show we count the customer whose DOB is for a particular, no, not this. Yeah, for all days of the week. So basically let's imagine the output. So we want day and number of customers born, right? So what do we want now? So we don't want the count of all the customers, which is very easy, count star. We want Monday, 2 people were born. Tuesday, 5 were born. This is what you were asking, Yogesh, right? Let's erase this part, this part, this part, this part, this part. Okay. Then we have Wednesday, so on and so forth. So can you now do this with the newfound knowledge we have of aggregate functions? So here clearly we have to apply count aggregate function. What do you group by? What do you group by now? We have to group, that is clear. Otherwise it will give you all the total count of all the customers. Here we have to group by something that is not in our table. So if you just select star from customer, so we don't have this day. How do we do that? Very, very good question, because this like clearly sums up group by plus day plus where plus whatever you want. Are you able to do it? If yes, then awesome, you have understood it. Otherwise, just watch the solution now and you will get it. So we don't want to do count star, that's for sure. This will give you total count. We want the count based on the day they were born. So how do I get the day they were born? Day they were born. This will be given to us by day name, right, of DOB. And this is exactly how on which we have to group by. So this will either give Saturday, Monday, Tuesday, which is exactly what we want. So now we can come here and say group by day name of DOB. So this did some stuff, but let's also show this as a column. And now we have Friday, 2 people were born, Monday 2 people were born, Saturday 2 people were born, Sunday, and so on and so forth. So you can also order by the same thing. descending. Okay, Wednesday comes first. So order doesn't make sense because we are expecting Monday to be first. There is a way to this, by the way. There is a way to this. How do we do that? Any idea, anyone? How do I order it so that it follows the actual order of the days? Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Anyone? Right, it is easy, right? Like you just have to, so these are pieces. You got the where, you understand what is group by, you understand what is order by, and you mix and match. This like puzzle. Once it fits, it fits. But yeah, how do you order now? So we have a function called day of week, if I recall correctly. Otherwise we will search, which will give you 03 18 7. So what is today? Today is 30th December 2023. Again it gives 7. So what is this? Let's see the documentation for this. Day of week SQL. And I was pretty sure W3 schools is going to come as the first result because it's a very good resource, SQL, HTML. So this basically, highlight this part. Weekday, or the one we used, day of week, this is same as weekday, right? Okay, no. What is day of week then? What did I do? Day of week function. Yeah, exactly the same. So 1 is Sunday, 2 is Monday, 3 is Tuesday, 4 is Thursday, 6 is Friday, and 7 is Saturday. So this should have given me 7. It is giving me 5. Wait, there is something that we are missing here. Let's figure it out together. Okay. So there are two functions, weekday and day of week. Day of week versus weekday. So weekday returns the index of the day in a fair given date. 0 is Monday, 1 is Tuesday. Let's read about it more. A relevant difference is that weekday counts the days from Monday. So as follows. So 0 is Monday, 1 is Tuesday. Okay, clear difference. So weekday gives you the count. So it considers Monday as the start day, and day of week gives you Sunday as the first day. Right? So now you can just go ahead and, so this is 5. So probably weekday is 5 means Saturday, which is very correct. So let's do it. So now you can guess what we are going to order by. Instead of the name of the day, we want to order by the actual index of the day. So now you get Sunday, oh, not descending. Yeah, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Good question. Like on the fly, we created a new question, answered it, and it is pretty cool, right? So you got the name of the day, the count. So Monday, 2 people were born, Tuesday, 4. Nice. Good question. Anything else? So prepare your own questions, answer them. Now it is cool. The second big topic of today. Joining two tables. Right? We talked about relationships, right? So I will draw the relationship we have right now here. Let's go to some white area. Let's draw 3 rectangles. 2, 3. We have 3 tables in this database. Customer, right? Let's duplicate this. Then we have branch. banks have branches, right? So they have like Jagdalpur branch or Pune branch or Mumbai branch. Then there is bank account. We should probably take a break at 40. We'll take a break, we'll come back and continue, right? Because I said we'll complete this today. So this should be a video. I will make edits to it later, but this should be a video that covers all the essentials, at least. Yeah. So we have three, what do you say, tables in this. So there is a customer table. So we can just say select star from customer. So it has an ID, first name, last name, right? So it doesn't refer to any table, right? So it doesn't have any reference. But as soon as you go to bank, even branch, right? So branch also doesn't refer to any table. If you see the columns, it doesn't refer to either customer or bank account. But when you select star from bank account, you will see it refers to the branch as well as the customer, right? So let's understand it even further, because the better you understand this thing, you joins are pretty easy. Let's come here, let's go here, bank account also. So these are called ER diagrams. So these are entities and you are trying to map relationships between them. So let's duplicate this. Let's change the font. So this is like, looks different. But yeah, so what are the columns in the customer that we care about? There is an ID column, right? Let's duplicate. I won't write all the columns. First name, duplicate, last name, etc. Right? Similarly, we have branch code, city, state, address, etc. So dot dot dot. But here is where things get interesting. This bank account has an account number, right? It has, where is it? AC number, branch customer ID, branch, we have to run, like at the very last 15 minutes we'll also do this crossover with Frappe, so stay tuned. Account number, branch, customer ID. This was AC number, so let's write it AC number. Okay, let's duplicate this. Let's see what else we have. Type and balance, that's fine. Type, allow. What did it paste? Come on. Delete. Okay. Type and balance. Cool. So two things we have to learn here: primary key and foreign key. So what's a primary key? This is like database lingo, but primary key is any key that can uniquely identify a row. So it should be unique. So each customer should have a unique ID. First name can be same for 5 customers, right? There may be 5 customers with the same name, John. So you can't rely on it to get a particular record. Similarly, employee ID, right? It is a unique ID for each employee. So no 2 employees can have same ID, right? First name, last name can be same. John Doe, 5 employees with the same name if you have 5,000 employees, right? It is possible, but the ID you allocate to them is unique. So that is the unique ID that can uniquely identify a record in a particular table is called a primary key, right? Similarly, branch code. So no two branches will have same code. So in this case, this is the primary key. So let's revert this, undo. Okay. So what I was doing is I was just, let's take a red color, primary key, and we'll just place it here. So in this case, this is the primary key. In this case, this is the primary key, and no two account numbers are same. So in this case, this is the primary key. Understood what is primary key? So primary key is anything that uniquely identifies rows or records in a table. Cool. And what is foreign key? Right now comes the foreign key. So the word foreign is like making it pretty clear that something outside of our territory, right? So primary key is inside the table. So customer has the primary key as ID, unique identifier, right? Of particular records or tuples, whatever you want to call them. But foreign key is outside the table. I'll tell you how. So here we have branch, right? It contains, so branch has 101, 102, 102 code. And here bank account has a column named branch, which actually refers to this thing here, right? Let's make it blue so it is clear. Noticed it? So this is called a foreign key. Let me just duplicate foreign key. So in official terms, right, it is a foreign key to which table? Branch table. Which column? Code column. So in official terms, we are saying that bank account has this branch, which is a foreign key to this another table, foreign, right? Other table in this code column, right? So this need not be unique. 5 branches can have the same, one branch can have multiple accounts, right? So this need not be same. So 5 bank accounts can have the same branch. So this is called a foreign key in SQL, that I am a key, I refer to this primary key, which is in a foreign table. And you need 2 things, which is which table and which column you are referring to. So I'm referring to the branch table and the code column. Can you tell me for this customer ID now? Customer ID refers to which one? ID column, right? So let's duplicate this. And once we are done with this, we'll take a break quickly. Foreign key to customer table. And this will be ID. Make sense? Just think about it a bit. I'll be back in 10 minutes. Till then, just go over this. Primary key, unique identifier for each record in this particular table itself. Foreign key refers to, like, references an external table's particular column. Usually this is a primary key column. So this is called a foreign key. Makes sense? I will be back. So I will hide myself. I will keep the screen visible. And I will also mute myself. I'll be back in 10 minutes. See you. Cool, I'm back. Anybody still here? Let me just refresh the page. Okay. Let's go to a SQL page and try to find where our stuff is. Okay, here is our stuff. Hi Shubham. Cool. Then fine, let's continue. So yeah, before the break, what we did was we were discussing primary key and foreign key. So primary key is anything, any column that can uniquely identify a particular row in a table. So customer ID is unique for every customer. So you can uniquely identify one particular record of a customer. Similarly, branch code and account number. These three are primary key for the respective tables. Foreign key. So foreign key is basically a key or an attribute. Attribute is basically column that refers to the primary key of another table, a foreign table. So foreign key, right? So you have to tell it two things: what table you are referring to and which column you are referring to in that table. Cool. This was it. So we formed a relation, right? Hence relational databases. Cool. So now the problem is that we have the table, right? We have this tables here. So now the question arises, how do I show the first name and last name of this customer along with the account number and the balance? What do you want? You want the account number, the balance, which is very simple. You can just say AC number and balance, right? And it will show you AC number and balance and customer ID. That is also easy. But now the issue here is that the customer's first name and last name reside in this table, right? Balance, customer ID and AC number are in this table, but first name and last name are in this table. This is where, so somehow we have to join the data of bank account and customer. This is where joins come in, the concept of joins in SQL, right? But in order to join, there are like a variety of joins. I won't go into like the theory of it. You can learn about it. There are something called cross joins, equi-joins, and natural joins, right? So let's start with a natural join. So I want this video to be everything foundational of SQL. Then you can learn bits and pieces even further as you want, right? Cool. So what we had here was basically this tables. Let's get this line here. Let's duplicate this line. Weird stuff. Okay, let me explain with a simple example. Okay. Here we have two tables, which is basically AC number, balance, right? I'm taking a simpler version of the same question, and we have CID, which is customer ID. This is not that CID, central CID India. Okay, this is the CID, Central Investigation Department, CID full form, Crime Investigation Department. Okay, this is customer ID, not that CID. Okay, then this is ID, and we have, let's duplicate this, first name. So what do we want? We want AC balance first name. So let's get some data here. AC number something something. Balance is 5,000 and customer ID is 1. Okay. Similarly, we have customer ID 1 again. So maybe customer ID 1 has two bank accounts. Okay. Let's duplicate this 5,000 2 times. So he has 1,000 in one account and 5,000 in one account. And then there is customer 2 and the account number. Cool. So 3 rows here, right? Cool. So this is the data we have. So it is easier to visualize. That's why I'm putting so much effort in it. But yeah, then you have some same thing here. So suppose this is the only data we have. Come here. John, Jenny, so what do you see here, right? So what we see here is that now if I were to ask you what is the balance for Jenny, what would you do? What is the balance for the account Jenny has? What would you do? You will look at this 2 table. You will see, okay, Jenny has an ID of 2. So let's write, this is the accounts bank account table. So let's be clear. And this is the customer table. Okay. What would you do? You will look at her ID that, okay, she has an ID of 2 and that you know that these 2 are related. So CID is a foreign key to ID. So you'll just go here and see which account has a customer ID of 2 and then you will see the balance 6,000 and you will tell me, right, that okay, Jenny has balance of 6,000. So you had to go from here to here. So this is whenever you have to refer between more than one table, joins come in. Cool. So let's do this. So how did you actually do this, right? So what you did was you came here. Okay, I was this row here. You used this thing to combine with this row here. Right? This is exactly what you did when I said it to you. And this is what we want SQL to do now. Right? So what did you use to identify that this 2 will join? What did you use? You use this thing, right? The foreign key. This is why foreign keys are important. You use this to match the rows. And suppose I said, what are the accounts that belong to John? You'll do the same thing. You'll come here. You will say that, okay, 1. So we have to look in the bank account table wherever the CID is 1. So 1, 1. So this also refers to this John. This also refers to John. Maybe I'm going too basic, but let's stick to it. This is just the concept now. So now we are joining is basically forming a new table, right? So this will form a new table with the combination of this stuff. First name, like account number, balance, CID, ID and first name. Cool. So let's copy. So balance will come here. Account number, CID. So just notice what I'm doing. I got 3 columns from this table and then 2 columns from this table. So when I join it like this is called joining the table. This is not a cross join. So this is an equi-join. So we are equating these 2 columns and joining based on that. So tell me what will be the resulting rows. when you join based on what I have done in the diagram? Tell me the first row. Anyone? Okay, I always drag the wrong thing out. So this will be the account number, this will be the balance. I have reversed it, so this should be AC number and this should be the balance. Balance. Okay. Go ahead, tell me. So CID will be 1. Come on. Okay, what did I do? And what will be the ID? Right? So 5000 came from here. This came from here. This came, so this whole row came here. And then we are joining this table as well. So ID will come from here. Okay. This is stubborn. 1 comes here, which should be same because that is the column we used to match. And then John will come from here. And now you can apply your select here, right? The question was asked that you want the balance, the AC number, the customer ID and first name, right? And now from this resulting table, after you have joined, so you join this too. After you have joined, you get the resulting table. And now you can select whatever you want from this table, right? As simple as that. So this was joining. So this is what we did. We joined, right? Joined on what? Where CID is equal to ID. That is exactly what we did. So we joined using this condition. We equated this column from this column and we got the resulting. So now you can predict the other rows as well. So this will be this. This will be this. CID will be 1. So let's draw the complete table. ID will be this. Name will be this as well. So this is the second row, which was matched with the first row of this. Then the last remains this. I knew it will drag that thing. But yeah, this is 6000. Come on, 6000. And then we have 2. Then we will have 2 here as well. And then instead of this, we will have Jenny. This is the 3 rows we will get after combining these 2 tables. Make sense? So now you have everything, you can select from it. Now just remains the part of writing the query to do this, right? Let's go back, do the same thing in our SQL. So now I want to, let's select everything from, so now one table is not involved, 2 tables are involved, right? So now you have to say, I want to select from bank account and customer. Or you can say, like this is better, join, right? Customer. What are you doing? I'm joining this 2 table where, right? So you can, let's try with the simple without the join. Where what? Where what? Customer ID or the CID is equal to ID. So in this case, this is the customer ID. Customer ID is equal to ID. And let's run this query. And what you see is we got all the columns from bank account as well as it matched and got the columns from the customer account. It matched it based on these 2 columns. So customer ID is equal to ID, whatever we did in diagram, right? This is exactly what it did. So we are picking from 2 tables and we are joining based on this. Makes sense? So this is equi-join or join. Then there are like more stuff here, but yeah, this is the basic thing. Now you can just answer the question. What do you wanted? You wanted AC number, you wanted first name, you wanted last name, and you wanted balance. Got it? We answered the question using joins. Cool. So I think this also works. Does the same thing, but this is more readable. There might be one more difference, but yeah, this syntax also works. So what you are doing, you are joining bank account and customer. Make sense? Join is clear. We are joining two tables. You can join n number of tables, by the way. Cool. Cool. Okay. So now we can play around. This was the last major topic. So if you didn't apply where, right? Like didn't apply this part and run the query, like remove everything, get the star, run the query. So now there is a problem. So it is, as you can see, it is not joining based on ID, which we didn't tell. So it fallbacks to its idiotic or non-smart joining, right? Which will basically go ahead and join each row of this with each row of this. So one row joins with this. Again, this row will be joined with this, which is called cross join. So search about it. It is basically not smart to do it. Takes so much memory as well as, yeah, slower. Cool. So this is what exactly we wanted, and we have it. Cool. Nice. We can also get customer ID, by the way. Customer ID. So this is. So now if you want to count and show by first name, how many number of accounts do we have? Combine it with count star. So sum of balance. We want to sum the total balance. Group by what? Customer ID. So we can use customer ID here as well. First name, last name. Also, if we want to use this thing in group by, you have to use them in, like, you have to group by them as well. This is one thing. So now you can see that Rahul Kumar has a total balance of 49,000, right? Cool. This will be always unique because customer ID, first name and last name combinations are unique. So grouping by based on 3 columns, it is not grouping by 1 column. So that's why we were able to show the first name and last name. Cool. Awesome. What else? I think this completes a lot of stuff that we wanted to complete. Let's do 1 or 2 more questions. Yeah, so there is a question. How does SQL know which is a primary key, which is a foreign key? Okay. Let's go a step back. So where did we start? We started with the data already there, the tables already created, the relationships already made, right? Let's take a step back. Start at the start. What did we run to create this? We ran this, right? So you see this. We have a create table command, right? So SQL has 3 types of commands majorly. There are more, but you just need to know 3. So let me just show you the 3. DDL, again theoretical, but maybe you want to know, right? DML. There is also something DCL, but I will focus on the 2. So DDL is data definition language. So create table, create database, update table, like alter table, right? This all come under database definition language, DDL. You are defining the structure of the data. DML is like select, update, delete. So database data manipulation language. and data definition language. So you are manipulating the actual data. In DDL, you are actually creating this relationships and etc. Right? Okay. So here, as you can see, while creating the customer table, I have created a column called int ID, and I told SQL that make this the primary key. Right? So SQL is not that smart. Okay, this is the primary key. The database creator or the designer has to decide on what will be the primary key, what will be the foreign keys. And similarly, as you can see, branch has a code which is primary key. And now when you come to bank account, right, you will see that it has its own primary key, but check the last two lines. You're telling that, okay, foreign key, this branch thing will be a foreign key to branch and code, which is exactly what we discussed while we were understanding this thing, right? Branch will be a foreign key to branch and code, like the branch tables code, and customer ID will be a foreign key to customer tables ID. Make sense? Does it make sense now, these two lines? This is actually defining a relationship between. So you are telling SQL that branch is a foreign key to this. So what benefits do you get? So benefit is that when you try to do some mess, right? Insert into customer. So insert into is a command which you can use to insert new rows in a table, right? Insert into customer. What do you want to insert, right? Let's first see what the structure look like. Select star, or you can see DESC customer. So we can know what kind of data we want to insert. ID, first name, last name, PAN, DOB. So insert into customer values. So ID will be 1. Let's say 1. John Doe. PAN number can be this. Date of birth can be 200101. And now I'll try to run this query. I ran it. I didn't see any result, because as you can see, error, duplicate entry 1 for key primary. So what did I do wrong? 1, already some customer has an ID of 1. But since we told SQL, we have told SQL before that this ID of a customer is a primary key, it won't let you violate that constraint. It won't let you set a duplicate primary key. Hence it threw an error. Similarly, in a foreign key, if you try to refer to a branch code which doesn't exist, it will throw an error. So that's why foreign key and primary key are important. So these are called constraints. You are applying a constraint to this column that, okay, this must be able to uniquely identify a bank account. This must be referencing an actual existing branch code. This must be an actual existing customer ID. Make sense? Does that answer your question, Salim? How does SQL know which is primary key, which is foreign key? The person who created it has to tell it. There are more constraints like not null, unique, right? That you can apply while creating a table, or while you can use the alter table command to alter an existing table as well. As you can see, this is how I entered the data, the sample data that you have. Make sense? So this was SQL. Now let's go back, practice some questions about joins. So Shubham says, how can I detect whether I have to use distinct in DDL of a table? Distinct, it depends on the domain, right? So domain, there are two types of domains. So in general sense, we talk about a domain of business, but in SQL, a domain is like what could be the range of values that a column could have, right? So suppose you want just one bank account per branch, then you have to make this unique, that okay, every bank account should have a unique branch. It may not be the primary key, but it should be unique. right? So you can apply a unique constraint here. Make sense? Primary key by default is unique. It won't let you duplicate it. But if you if you want some other column to be unique as well, you have a unique constraint. So that all depends on the use case and the database modeling. But yeah, once you have done that modeling, it is done in a way that there you will find many courses on database design, and it's a huge topic. There are special database administrators that just manage databases, but this should be a good foundational start. These are the core concepts that even like I think 95% of the stuff that I have used in SQL is like what we have learned from today. That is what it is. Cool. So Shubham says, example, create table. If not exist, select distinct column. This. Cool. So Wandering Soul says, hi Hussain, please make a video to debug the code in batch. It will show the required extension in ID. I did not find any good article on this topic to set up VS Code ID for. Do you want to debug the actual bench CLI or Frappe code, app code? Cool. Let's now jump to, like, this is my Frappe site. Now we are going to combine what we learned to do something useful, right? Yeah, let me create one video. I'll keep it in mind. Debugging. So cool. So I'll go into system console. I recently wrote an article about it, just read it. And you can run SQL commands from here against your site's database. So this is very similar to running this stuff here. But now you just need to know one thing to run SQL commands, that whatever doc type you have, right, whatever entities you have in your Frappe site, they have a database table in the backend created for you. Whenever you create a new doc type, say bank, let's say customer, module will be custom. I'm just trying it out, and let's create and continue. And now what you're doing here is you're actually adding columns to your database table. So let's add a first name. Add a data column similar to varchar. First name, it should be mandatory. This is a constraint. So we also have a unique constraint. We have not null. So this is all happening through UI instead of you writing the DDL code. That's the huge difference. So let's duplicate this, move this to another column. Last name, I don't want this to be mandatory. In the settings, I can define the primary key naming rule, auto increment, which will basically create a primary key ID like 1, 2, 3, 4, 5, 6 automatically. Okay, let's go back. Let's hit save. Let's go to customer list. Right, we'll create one customer from the UI. So Rakesh Mehta, like one was generated. This is the primary key. Then there are two other columns. So now if I go to system console, so you just need to know one thing. So if you try to do this right, let me just zoom in, select star from, what was the name of our doc type, customer, and execute this script, you will say whatever it is, it wasn't able to, so syntax error, we didn't switch to SQL. Yeah, customer doesn't exist. We created the doc type, right? So the only thing you have to remember that Frappe will name the database table prefixed with tab. So now if you execute this, you will nicely see the columns that you created and the data from that table that was created for you. So these are all columns added by Frappe for tracking who created this document, so who modified it, when was it modified. But yeah, you can select whatever columns you added, like first name, last name, and in Frappe the primary key is called name for every doc type. So as you can see, one, Rakesh Mehta. Useful, right? Now that you learned SQL, you can play around with system console. That's it. So you can join stuff. But yeah, let's do something interesting. So we have a feature. So this is like you have to run SQL, right? Who wants to do that? So suppose I want to count the number of to dos. Count star we learned today, right? Count star from what will be the name of the table? Not to do, but tab to do. So you can execute this. So I have 3 to dos. You can apply as number, how many, or whatever you want to call it, 3, right? So now suppose I want to group by. Let's see what data we have actually in to-do list. Group by priority. Let's try priority. So how many high, how many low. You see the usefulness of what we learned today, right? So you can group by priority. Yeah, so you have this. So let's do priority here. Wait, what are you doing? Okay, I pressed the wrong shortcut. High priority 1, medium priority 2. You could have done this with UI, but now you have the complete capability of SQL. So you can join tables here, right? So, but what's the use of this? We want to save it somewhere, right? That, okay, whenever this is kind of a report, right? I want to save it somewhere. How can I do that? In the report feature of it, one of the report types, report feature of Frappe, one of the report types we have is a query report, which is basically write a SQL query. Will give you a nice UI on top of it. Let's call it to dos by priority. Like very simple example, you could have done this with no code, but since we are just learning it, so let's say to do not standard, and I will just go ahead and paste that query from my system console here. Let's leave it empty right now, but let's go to system console. So I have written about this in the blog. So let's copy this and paste it in this query, save, and when you click on show report, you will see the exact thing that it is fetched, right? Not an eagle, but it's a parrot. It's not an eagle. It sounds like, it makes sounds of cats. It makes sounds of eagles maybe because that's what you heard. So it pretty weird guy or gal, I don't know. Okay, parrot, yeah. So high is 1, medium is 2. Now you can join stuff whatever you want. So joins are useful when you want to do child table stuff. So for that you just need to know how they are linked. So child table rows have a parent for key for parent, so they link to each other. Cool. Very versatile, but like Frappe. Yeah. Okay, so now you have query report, so you can go to report list and find this report. You wrote a query, it gave you a report, and it has other features as well. So you can apply filters. So suppose you want to filter the priority, right? So let's say there is a description. It is a data. Field name will be description. So this is like no code, low code features provided by Frappe. And if you mark it mandatory, you click on show report. Let's refresh. And now without giving the description, let's say H, right? I am not getting any output. So this is not being used right now. So what do you need to do? You just need to say like, where, we learned it, right? Where description. So there is a field called description that I know in to do that basically describes what this to do is. Like operator. So this is some special syntax. Like. So you can use this dynamic filter that Frappe will give you, right? So you can do this. I think probably this should work too. And now, okay, wait. So go to edit and just do this wildcard filter. So this will automatically place two modulos before and after your this thing. Let's hit save, show report. I will refresh. H. What did I do? Probably something wrong. Okay, S. I forgot an S. So you have to tell, like for string it is S. Let's go back. H. So this isn't useful. Let's see what we have. Live, right? I want to only kai which have live. No, quotes. Frappe will automatically add the quotes for you here. So this will be replaced by, so if you enter H in the filter, it will give you H, this thing. So this whole thing will be replaced by this, by Frappe before running the query, because we clicked on this thing. If you didn't do this, it will just replace it with the actual H. Make sense? Cool. Let's go back. And now I want to just say live. Whatever to-dos contain the word live in the description, just show me. Just one, right? And let's say, what else? T. Whichever to-dos contain the word T. Come on. Okay, I have to refresh. Description contains T. Did we mess with the query? Yeah, we did. We removed the wildcard filter, so it was exactly looking for the word T. Ha! Now you understand the difference as well. So there are three to-dos which start with, like, which contain the letter T. Probably useful, probably not, but you learn the concept, right? You can use these filters here. And more power, you can rename these columns using this. So suppose you want the priority, this should match this thing with priority. This should be a data field. H. Now this is priority, and bear in mind, now this will ignore the columns you don't define here. So let's say number of to-dos. This can be a not data, integer field. Okay, I have to reverse this. So label comes here and the actual name of the column comes here. Let's refresh. H, and as you can see, number of to-dos, priority. And the UI is again, so you can apply this stuff here, greater than 5, less than 5. So this is given by, provided by Frappe's report view. So filters, columns, this is all you need to do to make good query reports. SQL and these two features, filters and this. Done. We are done for today. The live stream has went on for 2 hours and 25 minutes, which is cool, I guess. I will cut out 10 minutes that I was not here and some more stuff. Yeah, sure. I'll show you my VS Code setup. Any questions? Did you learn something new? If you did, and if you're watching it later, probably just drop a comment. I always like comments on my videos, so I always read every comment. No, we call him Mithu. So Kenneth says, if I, hey Kenneth, you are here, very silent. If I create a script report in ERPNext, what is better? Make SQL query first until final and show to report, or I use Frappe get all, get list piece by piece and show to report? I didn't get your question exactly, Kenneth. So if you are using a script report, like if you know you are comfortable with SQL, that is fine. Otherwise, I will recommend go with script reports that then you can use the ORM, right? So it depends on what your use case is. So you will figure it out. If it is something simple that you can just do with joining two stuff and getting the columns, go with query report. No issues if you can do that. And if it is something that, okay, after data comes back, I have to process it using some Python, then just use a script report. I think script report we haven't covered, but this is similar to server scripting. So data, same thing I can do, frappe.get all. So here you don't have to remember that, okay, it is called tab to do it. Just takes the name of the doc type. You can tell the fields. Behind the scene, it will generate the SQL query for you. But now you understand SQL, so you know what's happening behind the scene. Fields can be status. This also gives you group by, etc. But yeah, when you want to do complex joins, SQL is the way to go. And if you are already comfortable with SQL, then it's easier to pick up. Right? Then you can process, and then you can store the result in a result variable, and Frappe will pick it up and display your result. So we could have gone more into script report, but this is not the video for that. But yeah, pretty cool stuff. What we learned today. You want to inspect your SQL for Frappe? Bench dash site. Suppose we want to inspect for this. Just type MariaDB and it will take you to the MariaDB console of that database. Whatever your site's database Frappe created will take you, and now you can say show tables. So the base is the same. Nothing magical that Frappe does. As you can see, the list of tables. You can select star from tab to do. Probably I won't find anything because I had maybe not created it. But user, you get the users. Cool. Goodbye. Have a nice day, everyone. Okay, before I go, my VS Code setup. So I think I recently changed my color theme. That's the only change I have done in Lotto. So I changed it to dark modern. Previously I was at bench console gives you the Python console. This gives you the MariaDB database console. Cool. So where was I? Okay, yeah. Then I have some extensions like Pylance and Astro and Rough for formatting the Python stuff. Then I have a Docker extension. But yeah, if you see the font, right? If you see the font, I have a different font. So this is Mona Sans from GitHub. Mona space. That is the name of this font. So UI settings, font, Mona space, right? That is that. But yeah, this is pretty much simple setup. Nothing fancy. Pylance is the main thing that brings the IntelliSense in Python code. That's the extension. Cool. Happy New Year, everyone. Have a safe year ahead, full of growth and learning, of course. So yeah, I'll see you next year on 1st of Jan with Suraj, where we will live launch Frappe Builder. Hope you had fun in today's session. My throat is now dry. Of course. And not vending Sola, any particular related to Frappe, no. Yeah, one is there, Frappe test runner, which I use to run the tests, unit tests. That is the one. Okay, how can I forget that? That is created by Ankush. Cool. I'm just closing all the tabs that I have open in my VS Code. So see you on 1st Jan. Do come. The whole stream is going to be revamped, the setup I have. So I have started from scratch on setting up OBS again for 2024. So all these graphics that you see will be gone. New graphics, new stuff coming soon. 12 with Hussain. enough marketing. We'll see you later. Bye. Okay. Cool. Have a nice weekend, everyone.